A neighbor asked me to convert his old skill screwdriver with a dead battery to work with lithium-ion batteries. He brought the batteries from his laptop, and then it's a matter of technique. First we throw away the old ones, we won't need them anymore. Leave only the contacts, they are carefully unsoldered. Then we cut this battery from the laptop. In this form, it will not fit into the battery case. By the way, the batteries will be connected in parallel too at the request of the customer to increase the total capacity. And I try on the obtained sandwich in the case, all fire, and the old wires can be unsoldered and thrown away. On the balancing board, I solder 2 thin wires and 2 thick ones. The thin ones will be used to control and balance the lithium, and the thick power wires will go to the outermost terminals of our prefabricated battery. On the terminals going to the screwdriver, you should also take thick wires of sufficient cross-section because they will flow a large current. I fasten the battery sections together with double-sided tape, and over it I will additionally wrap insulating tape. Connected the batteries, minus, plus, minus. It's all connected in series, the plus of one with the minus of the other. I also made the jumpers thicker. As for the connection to the board, everything is simple. Plus and minus going to the screwdriver, them will be charged. This is connected to the minus of the battery here. The plus is connected to the plus side. The balancing 4.2 volts are connected here. 8.4 to the next connection for successful balancing. I don't know how successful it will be with 2 parallel banks, but I was asked to do it this way. There is one thing with connecting the battery. You need to follow the order of connecting the wires. Otherwise, nothing will work. First, you need to solder the minus lead, then 4.2 volts, then 8.4. Next, battery solder here, and only now the power plus lead. I don't see any indication on the board, so maybe it's already working. Let's check it. No load, 11.6 volts. I'll connect the light bulb. Yes, everything's fine. Trying it on, just like in the cabin. Now we need to modify the charger because lithium needs to be charged with a certain current and voltage which the native charging station is not able to provide. We will need another Chinese board. It is a step-down converter with current and voltage regulation. And a little bit of wizardry with the charger board. We need to unsolder the plus wire, the minus wire, and connect them to the output of the converter. The wires were short, so I soldered the other wires. I'll also connect 2 wires to the input of the board. The plus wire will be soldered to the same place where the plus was, and the minus to the charging connector. In the case of the station, drill the hole, drop there a drop of thermal glue, which in this case acts as a diffuser. So let's see what happened. When you connect the power supply, the green LED lights up, which means the end of the charge, if the battery is connected. The red color signals current limitation or short circuit on the output, and the blue LED indicates that the charging process continues. I didn't wait for the battery to fully charge. I wanted to test it in operation faster. I took some 40mm self-tapping screws, which the screwdriver with the new battery coped with without any problems, even without slowing down. But with 70mm I had problems. The current protection on the balancing board kicked in. It is possible to load it, but the batteries are not high current and may explode from excessive load, so I leave everything as it is. The battery voltage is 12.5 volts. we can continue the test. I'll unscrew it first. And then I'll screw in all the 40 screws I have left in the box. "38 of them, like parrots. And now I'm gonna unscrew them. You've gotta put them back in the box, haven't you?" That's a little bit of work. Good luck everybody, goodbye.